Hi everyone, my name is Alajohi AJ for short, and in this new series, I'm going to explain the concepts and results and the skills and so the exercises of the most famous book of mathematics, Thomas Calculus. I'm following now the 14th edition, which is the latest edition in 2009, and I'm going to start this lecture. Okay, let me just explain how how this series will be. First, I'm going to explain in each concept or in each section. I'm going to make tutorials about the concepts and the skills, and then I'm going to move to solve the equations or solve the equations, solve the exercises, not the examples, just the exercises on the back of each section, which is really a lot of exercises. So the main task or the main goal of making this video series is because there is no one, I haven't seen anyone on YouTube that solving all the exercises of the calculus. This is my first lecture, and the plan will take a lot of time, but we're starting this task or starting this series. We're not restricted in solving the exercises of the first chapter. We can move to the second chapter, to the integration, for example. That depends on the comments that you will leave, and it depends on the views and the need that students ask me when I in the middle of doing these lectures. So I'm going to do a lecture, maybe two, maybe three parts, I don't know, okay, about the skills and concepts, or concepts and skills. And then I'm going to make tutorials sequentially behind after these tutorials to solve the questions. So if you don't need to understand, or you're okay with the concept and skills, you can just move to the exercises and see the solutions. And if you say no, I'm okay, I can see the skills and the concepts, I need extra explanation, maybe another point of view, so you can stick with me here, and we can just pass these skills and concepts ideas, and then move to solving the question, the exercises. So the first thing I need to make revise to is relation. The relation. What do we mean by a relation? A relation is just a simple connection between two sets. How? For example, let's say relation. We have a mathematical definition, and we have just a simple definition. Let me say it is a simple connection So the relation, it's a simple connection between two sets. For example, if we have this set A and we have the other set B, and we have here x1 an element and x2 another element and x3, and we have here y1, y2 and y3. So if we connect these elements, for example, for simplicity, we will get a relation. Where is the relation? The relation is a set of order pairs. So x, y belongs to the product of these two sets, such that the first part of the order pair belongs to the set A, and we can write it just and, like this logic notation, and y belongs to the other set. It's just a simple connection, could be with a rule and could be without a rule. For example, let me do I have something? I don't want to forget something. I'm going to start with this one. Okay. So if we wanted to draw our graph, let's say graph this relation, I'm going to consider this. I'm going to consider this set A here. This set could have more than just x3. It could be x4, x5, x6, and this set also y4, y5. It doesn't matter. So these elements are not connected, and these elements are not connected, and this is still a relation. So this is the set I, which is the set that I connect the elements from. Okay, and this is, let's say, this is the destination and this is the source. So I move from here to here, the connection. It's just a connection, but let's consider it's just a destination and source. So x1, x2, x3, x4, x5, x6, and here y1, y2, y3, y4, y5. And if I want to graph this relation, the graph will be x1, for example. Yeah, that means R. If I want to make it explicitly, I can write the relation this way, which is the, I can define the order pairs. This is the definition of the order pairs, okay, in general. But for this relation, let me call it R1, which doesn't connect every element from this set with every element from this set, because according to this definition, every element from the set A has to be connected with an element from the set B, which is not the reality in here. So I will denote it R1. R1 will be x1 connected with y1, and x2. This is the definition in general. This doesn't mean this relation. This relation, I will write it right here. y2 and x3 with y3. So this relation has three elements, three order pairs. So the elements of the first set represented as a line in here, and the elements of the second set represented as a line, a vertical line. This is the set B, or the set B. And the elements of the relation R1 will be order pair, x1 with y1. This is the first element, and x2 with y2, x3 with y3. See? So R1, which is the relation, is a subset from the plane. Okay? A is a subset of them from the real number, which is R, and B is a subset from the real number R. The plane equal to multiplication between R and R. We call it Descartes multiplication. Okay, this is the relation. This is a very simple concept, okay, and it will be the base to our concept today. This relation could be with a rule and could be without a rule. Okay, so now I consider this relation is just a simple connection without any rule that connects between these two elements. Two numbers. We're going to say it numbers, not elements, because we are constricted here with real numbers. So I'm not gonna say an element. The right term is the element, but it's too general. So I'm going to say number because we are dealing with the real numbers and functions. The function, okay, coordinate. So now let me say or clarify something. Now the connected set is a subset from A, and the connected set here, it is a subset from A. This set, we called it the domain. Okay, this set, the set of the connected elements from the left side, okay, from the source, and this is called the range, which is the connected elements from the right side, which is the destination. Okay, so we have the domain and the range. The function, now I'm going to write a definition. So now we've finished writing the definition. The definition says a function f from a set D to a set Y is a rule that assigns a unique value of x in Y to each x in D. So it is a rule. We have here the domain D, and we have this set Y, which could be the range. So we have here elements. Let's say here elements x, 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 and we have here of x, which is the effect or the value of this x. So if I apply the rule, to this x, the result will be f of x. So what's the difference between the function and the relation? The function is a more advanced concept. The relation is just a simple connection without any conditions. But we can see here that there is two conditions that the relation must satisfy to turn to a function. The first, all the numbers here should be connected, not like the relation. A function f from a set D to a set Y is a rule that assigns a unique value of x in Y to each x in D. So the function after finishing this is another review, another point or point of view of understanding the connection between the relation and the function. As I said before, that the relation is a simple connection, could be with a rule and could be without a rule, and this relation must satisfy two conditions to be called the function. Function is more advanced concept. The function is a relation that satisfies the following conditions. For each x in D, there will be f of x equal to y. So mathematically, this is in mathematics, I would say for every element here, it's connected to f of x here. So there is, okay, so f of x belongs to y. The second condition, for every x in D, there exists just only one y, such that y equal to f of x. I mean by y, I mean this element. So let's imagine that this function is just a camera. So I need to have like an image for each, or we call it a mapping. This is called a mapping sometimes. So for every element in here, there should be a value that connects with x, and the other condition should be just one value. So in mathematics, we say for every x in D, there exists just one y, such that one image, one destination, just one destination. Or in mathematics, for all x in D, if we found and all y1, if I found that y1 equal to this image and y2 equal to this image, so y1 should be the same as y2, which is the same value, I mean, for every x there is just one value as a destination to this element. So if the relation satisfies these two conditions, I can call it a function. In modeling and calculus and engineering and physics, we don't normally deal with the relations, because we need the most advanced concept of the function, which has a lot of properties that allows me to get the most benefits from mathematics as a tool to solve and model the physical and engineering and biomedical and a lot of applications in science. So now we can consider the function as a machine. Now we can consider the function as a machine f, which has input and has output. We don't care anymore. We're not going to go back and say this is a relation and this is a function. It's just a machine that we feed it with some numbers and it gives us another numbers. Okay. Another main difference between the relation and the function, you can see here, the domain of the relation could be a subset of this set, but in function, this set should be all a domain. Okay,